Hey there, it's Mr. Ray, and we're back again with another math video. Today we have trigonometry, SOH CAH TOA. So when we do these trigonometry lessons, homework, study for exams, do these problems, we have to realize we're dealing with a right triangle. Okay, a right triangle that I wrote in the bottom. Right triangle. What is a right triangle? Right triangle has one 90-degree angle. Okay? Now, a right triangle doesn't mean it's never wrong. Okay. Anyways, right triangle is basically has one 90-degree angle, and the other two angles are going to add up to 90. So what you need to understand first is you always have a hypotenuse. The hypotenuse is the diagonal side opposite the 90-degree angle. Always. So when we have a 90-degree angle, we're going to have a hypotenuse that's opposite that. This side right here, that side, okay? That side is the hypotenuse. Now, we need to know two other sides, an opposite and an adjacent. Well, it depends on the angle that we're looking at. So the next thing really depends on the angle. Let me call this angle right here, this angle, theta, okay? Angle theta, angle, this angle. Now, let me go ahead and label the sides in relation to that angle. This side right here is going to be adjacent. Okay, adjacent. And this side, in relation to this angle, is the opposite. The opposite and the adjacent can switch sometimes depending on the angle we're looking at, okay? So remember, when you have a 90-degree angle, the side opposite that's diagonal, that's always the hypotenuse. But the adjacent and the opposite can switch depending on the angle. Let me show you. Okay, before I explain any more in this lesson, I got to be really clear. The hypotenuse is going to equal h from now on. The adjacent side is going to equal a, and the opposite side is going to be o. We're going to use these letters, okay? Now, let's go back to this triangle. We've got a 90-degree triangle again, right? Okay, where's the h? Let's label the h. The h is always in the same place, opposite the 90-degree angle, okay? There's the h. Now, what angle are we looking at? We've got to know that, and they're going to tell you in the problem. We're going to look at this angle up here. We're going to call that angle theta, okay? Now, where is the adjacent and where's the opposite in relation to that angle? Well, the A is the one that runs along the angle, okay? Along the angle. Or think about the angle that you're looking at is always between A and H, like that. Now, O is the opposite side, the opposite, and that's going to be this side down here. Okay, so now in relation to this angle, we have an A, we have an O, and we have an H. It's a little bit different than the last example because it depends on which angle we're talking about. Are we talking about this angle? Are we talking about that angle? The A and the O will switch, okay? And that's all. The A and the O are the only ones trading places. Now that we know that, we can tackle some problems. Okay, going back to that triangle, if we're talking about this angle here, then again, we need to know that because it's a right triangle, yeah, it's got that little square right there, then we're going to have an H across from it. We're going to have an A here because the angle we're talking about is between H and A, and then we're going to have the O. Now, let's take a look at sine of that angle. Sine of that angle is going to equal the opposite over the adjacent. SOH CAH TOA. SOH CAH TOA. What does that mean? Sine is equal to O over H. Cosine is equal to A over H. Tangent is equal to O over A. Okay? Now, what if we had lengths? We had numbers. Let me show you. So instead of letters, we had numbers, 10, 6, and 8. Okay, Well, sine of that angle is the opposite, which is 8, over h, which is 10. A over h is going to be 6 over 10. And the opposite, TOA, is 8 over 6. Okay? And you can reduce those fractions. Let me give you another example. Okay, given another example. In this problem, we know we have a right triangle, and we know that we have one 30-degree angle. That means definitely this has to be 60 because the other two angles besides the right angle add up to 90. So we have a very typical 30, 60, 90 triangle. So we also know that we have a hypotenuse is 12 and the opposite of the 30 is x, or the adjacent of the 60 is x. We need to solve for x. Okay, let's do that. Well, we know sine of an angle is equal to the O over the h. So sine of the 30 is equal to, what's the opposite of the 30? Opposite the 30? Yeah, that's going to be x over the hypotenuse 12. There we are. Okay, now you need to know sine of 30. You can put it in a calculator, but you need to know sine of 30. Sine of 30 is 1/2. That's what that equals. So 1/2 is equal to x over 12. Or, what else do you know? Well, then x is equal to 6, because you can multiply both sides by 12. Okay. Okay, welcome back. Now, again, we have a right triangle. One angle is 30, the other angle, yeah, it has to be 60. We have a very familiar and very often used 30, 60, 90 triangle, okay? Now, what are we given in this particular problem? We're given the hypotenuse is 10. That's always the hypotenuse, that diagonal, okay? And we know we have an adjacent to this. The adjacent to the 60 is x. That's kind of the same problem as before, but it's a little bit different because the hypotenuse has a different value. We know a couple things, okay? We know that sine of 30 is equal to x over 10. Let me give you another one. We know cosine of 60 is equal to x over 10. Now you need to know your sines and your cosines of 30 degrees and 60 degrees. So what is this? Well, did you know that sine 30 is equal to cosine 60 is equal to, yeah, 1/2. Okay, they have to be the same. They're the same. So I have 1/2 equal to x over 10. And of course, x is equal to 5. Let me give you one to try. Okay, welcome back. Now, did you miss me? I'm just joking. Okay, so we have a 90-degree angle. It's a right triangle. We have 45. So what we want to do is we want to find x. Okay? Given that we have an adjacent side, that's A in reference to that angle. And this is always h. Okay? Remember, the angle is always between, that we're looking at, between h and A. Now, knowing that this adjacent side here is 7, and we need to find x, go ahead and try that. Pause the video, I'll be right here. Great, welcome back. Okay, now, well, we know we have the A. A is equal to 7. H, we don't know, but we're trying to find O, that's x. We're looking at O and A, okay? So we're using a tangent. O and A, SOH CAH TOA, O and A, okay? Tangent of 45 is equal to TOA, O over A, x over 7, okay? But what is tangent of 45? This is one you gotta know. That's 1. 1 is equal to x over 7, and x is equal to 7. Okay? x is equal to 7. And by the way, when you look at this triangle, if you have a 45-degree angle in a right triangle, the other angle is always 45 as well. Two 45s and 190 give you 180. Okay, in the next video I'm going to, I know this is maybe for some of you, this was kind of easy. I'm going to tackle some much more difficult problems as we get into this. But for right now, if you have any questions, please let me know. Again, my name is still Mr. Ray. If this helps you out, please like and subscribe, and I'll see you in the next video.